Welcome to Science for Sleepy. You are here because, like so many others, you wonder what the Earth might look like in the year 3000, nearly 1000 years from today. It feels impossibly far away. Yet the truth is, if you look back to the year 1000, you'll see that our planet has already transformed in ways that would have been unrecognizable to those who lived then. Castles have crumbled, empires have risen and vanished, continents have been mapped, and species have gone extinct, while new cities and new languages have grown out of the soil of history. But the most shocking truth, the one that might unsettle you as you settle in to listen, is this. Almost everything you see around you today, the roads, the skylines, the machines, even the languages you speak, will likely be gone by the time the year 3000 arrives. Even your descendants, if humanity survives that long, may no longer be recognizably human. And here's another unsettling fact. If you project the current pace of species extinction forward, more than half of Earth's animals could be gone within the next few centuries. In 1,000 years, entire ecosystems might be erased. That means the forests you know, the oceans you imagine, and even the landscapes that feel timeless deserts, mountains, rivers will shift so dramatically that the Earth of the future might feel like an alien planet. Before we go further, can I ask you for something small? If you could, pause for a moment and go down to the comments section. Tell us where you're watching from and what time it is there. It's strangely comforting to imagine listeners scattered across the globe, lying in bed or sitting in a quiet room, all of us trying to picture the same far-distant world. And while you're down there, I'd love if you subscribe to Science for Sleepy. Think of it this way. If people in the year 3000 look back at us and wonder why humanity vanished, maybe it's because you didn't hit that little button. Do it for the survival of our species. And remember, we upload a new science story every single day, so if you're still around tomorrow, we'll be here waiting for you. Now, let's walk slowly through this question. What will the Earth look like in the year 3000? The easiest way to start is to look at how much has already changed in the past 1,000 years. In the year 1000, Europe was in the depths of the Middle Ages, with most people farming fields by hand and living in wooden huts. In China, the Song dynasty was experimenting with early gunpowder and movable type printing, small inventions that would quietly shift the entire course of history. North America was filled with thriving indigenous cultures, with no knowledge that their world would soon be invaded and remade. In Africa, powerful kingdoms such as Ghana were controlling gold and salt trade routes. At that time, there was no electricity, no machines, no global communication, no skyscrapers. Even the concept of a nation as you know it today was still primitive, and yet, if someone from the year 1000 were dropped into your world, it would feel like arriving on another planet. Cars and airplanes would seem like magic carpets. Satellites circling overhead would look like glowing stars under human control. The internet, carrying words, voices, and images instantly across the globe, would feel indistinguishable from sorcery. So imagine the leap between 1000 and today. Now stretch that leap forward another 935 years. The shock is not just that things will change, but that they will change beyond anything your imagination is prepared for. Science tells us that even when progress feels slow on the human scale, the Earth itself is constantly in motion. Continents drift a few centimeters every year, but over 1,000 years, that means entire shorelines redraw themselves. Ice caps expand and shrink, oceans rise and fall. The Sahara Desert itself has not always been a desert. There were times when it was covered in lakes, forests, and rivers. In 1,000 years, the deserts of today might be fertile green lands, and the farmlands of today could be barren. But here's the detail that might strike you most. Climate change is not just a story of the next 50 or 100 years. It is a story that echoes through centuries. Scientists who study atmospheric carbon can track levels going back hundreds of thousands of years, and those records show patterns of warming and cooling that reshape entire civilizations. Rome, for example, reached its height during a period of relatively stable climate, when crops could grow predictably and food was abundant. When climates shifted, so did the strength of empires. That same force is at work today, except the changes are faster and more extreme because they are driven by human activity. By the year 3000, if humanity survives, it will have adapted to an entirely new balance of land, water, and air, one that may be hostile to many of the creatures alive today. One of the dull but deeply significant realities is soil. Yes, soil. Dirt may not capture your imagination the way spaceships or robots do, but soil is what feeds you. Already, topsoil is being lost at rates faster than it can be replenished, thanks to industrial farming and erosion. In 1,000 years, unless humans develop ways to restore or manufacture soil, natural farmland might vanish. That means food as you know it today, wheat, rice, corn, might no longer grow in the same way. People of the future might survive on engineered crops, laboratory-grown protein, or entirely new foods that we cannot imagine. It sounds dull compared to visions of flying cars, but soil might matter more to the survival of humanity than anything else. Now, consider energy. The world of the year 3000 will almost certainly not be burning oil, coal, or natural gas. Those fuels will be long gone, exhausted, or abandoned. Instead, future civilizations might live on solar power harvested directly from space, or nuclear fusion, or perhaps something stranger tapping geothermal heat in ways we cannot yet achieve. Imagine a city that hums quietly, its lights powered by the constant pull of the Earth's molten core. These details seem small, but they are the fabric of survival. And yet, behind all of this looms the central question: will there even be human beings left by the year 3000? Extinction is not just a word for dinosaurs. It is a natural process, and every species, eventually, disappears. Most species survive for a few million years before vanishing. Modern humans, Homo sapiens, have existed for about 300,000 years. That means, in evolutionary terms, you are already in the middle age of your species. Extinction is not unlikely, it is inevitable, unless humanity changes form, adapts, or spreads to other planets. The year 3000 is not that far in the grand timeline of life, but it is far enough that the humans who may exist then could be genetically, biologically, and culturally transformed into something else entirely. If you let yourself imagine lying down in a meadow of the future, 935 years from now, you might look up and see a sky dotted not only with clouds, but with enormous artificial structures, orbiting Earth, harvesting sunlight, or guiding weather patterns. The air may taste different, filled with chemicals you do not know. The animals around you may not be wild creatures, but engineered hybrids, created to fill ecological gaps left by extinction. Perhaps the meadow itself will be artificial, designed as a park inside a vast dome because the outside climate is too harsh. All of this sounds speculative, and it is, but it is speculation rooted in the patterns science shows us. Change is constant, extinction is natural, and survival requires adaptation. The shocking fact is not that the Earth will change in the year 3000, but that it will change so much that your imagination will almost certainly fail to capture it. And here's the question to leave you with at the end of this thought. If the humans of the year 3000 are so different from you that they no longer look, speak, or live as you do, can you still call them human? If you want to picture the Earth in the year 3000, it helps to step backward first. 1,000 years ago might sound like a long stretch, but in the scale of our planet, it is the blink of an eye. Still, for humans, even 1,000 years is enough to transform the world beyond recognition. Let's take a quiet walk through that time. In the year 1000, the city of London was little more than a walled town beside a river, its skyline shaped by wooden buildings and small churches. Today, that same city glows with glass towers, underground trains, and electric lights that can be seen from space. The same pattern is repeated everywhere. The city of Beijing, which now holds millions of people, was in the year 1000 a capital under the Song dynasty, alive with markets, scholars, and early experiments in paper money. But it was still a city of horses, oil lamps, and wooden carts. If you look across the ocean, the Americas in the year 1000 were thriving with civilizations rarely mentioned in history lessons. The Mississippian culture built vast earth mounds near what is now St. Louis. Farther south, the Maya were still carving their histories into stone, though their great cities were already beginning to fade. The Inca Empire had not yet risen, but its foundations were being laid high in the Andes. These societies grew food without modern machines, mapped stars without telescopes, and built cities that rivaled anything in Europe. Why does this matter for your picture of the future? Because it shows you how quickly landscapes, cities, and cultures can rise and vanish. In the year 1000, there was no concept of global communication. People might live and die without ever knowing that other continents existed. By contrast, today, you can watch a storm on the other side of the Earth in real time. That leap happened in less than 1,000 years. So the leap to the year 3000 will be just as great, if not greater. Now, let's move away from human history and consider the planet itself. The Earth's climate 1,000 years ago was in what historians call the medieval warm period. Temperatures were slightly higher in some parts of the world than in the centuries that followed, and that warmth allowed vineyards to thrive in parts of England. Crops flourished in some regions, while others faced droughts that pushed entire cultures to migrate. Then, after a few centuries, came the Little Ice Age, a long stretch of cooling that brought harsher winters, frozen rivers, and famines. The River Thames in London froze so solid that markets and fairs were held on the ice. Imagine that. Entire towns gathering on what should have been flowing water, roasting meat, selling goods, and even building temporary houses right on top of a frozen river. What does this tell you? It tells you that even small shifts in temperature, just a degree or two across centuries, can change human history. Empires rise in times of stability and decline when climates shift. The Vikings, for example, built settlements in Greenland during warmer centuries, farming and raising cattle. But when the climate cooled, those settlements could no longer sustain life, and they vanished. That story, repeated in different forms around the globe, shows you how tightly human survival is bound to the rhythms of Earth. Fast forward again, and you reach the Industrial Revolution, the moment when humans began to change the Earth, not just through farming and building, but through machines. Coal mines lit the skies with smoke. Railroads stitched continents together. Cities grew faster than ever before. By the year 1800, the world already looked nothing like it had in the year 1000. And if you leap forward another 200 years to the year 2000, the leap feels even larger. Humans not only reshaped the surface of the planet, but also reached beyond it, sending satellites, probes, and people into space. Think about this. In less than half a millennium, humans went from sailing ships powered by wind to machines that could land on the moon. That acceleration tells you something important about the next 1,000 years. If so much can happen in a few centuries, what unimaginable changes could come in nearly a millennium? The Earth itself carries marks of this acceleration. Take forests, for example. 1,000 years ago, Europe was covered in thick woodlands. By today, much of that land has been cleared for farms, villages, and cities. Rainforests in South America and Asia, once vast and untouched, have been cut back dramatically in just the past century. If you extend that pattern forward, the forests of the future may look very different, perhaps engineered to grow faster, perhaps entirely artificial, or perhaps replaced by other landscapes altogether. Rivers too have been bent and reshaped. The Nile, the Mississippi, the Yangtze, once they flowed freely, dictating where civilizations could grow. Today, they are dammed, diverted, and controlled by human hands. In the year 1000, no one would have imagined machines that could hold back an entire river or flood a valley to create power. In the year 3000, the rivers of Earth may no longer flow as nature intends. They may be redirected through underground systems, harvested for energy, or even replaced by artificial waterways. Another way to look at this thousand-year change is through the animals that walked the earth. In the year 1000, mammoths were already gone, but species like passenger pigeons still darkened the skies of North America. Those birds are now extinct, erased by human hunting. Wolves once roamed freely across Europe, lions across Asia, and whales in numbers that dwarf today's populations. In just 1,000 years, human activity has reduced or eliminated countless species. Imagine what another 1,000 years will mean. Will elephants still roam, or will they be distant memories? Will future humans, if they exist, know of these creatures only from fragments of fossil bone and digital archives? These reflections can feel heavy, but they are necessary, because the truth is, the year 3000 will not be a single, dramatic event. It will be the outcome of thousands of small, slow, seemingly dull changes that accumulate into transformation. Soil erodes, forests shrink, rivers are dammed, climates warm or cool, species vanish. Each detail is boring on its own, but together they rewrite the entire face of the earth. And yet, if you pause and think, this is what makes the question so haunting. Humans rarely notice change while it is happening. The people living in the year 1000 did not wake up and think, the climate is shifting, the forests are vanishing, the rivers are being reshaped. They lived day to day, as you do now. Only centuries later can we see the patterns clearly. So if someone in the year 3000 looks back at us, what patterns will they see? That brings us to a quiet but troubling thought to end on. What if the greatest changes of the next 1,000 years are already underway, happening so slowly that you cannot see them? When you imagine the Earth of the year 3000, the first thing you must picture is heat. Not fire, not sudden catastrophe, but the slow, creeping warmth that reshapes everything. Climate change is not a story of one storm or one drought, but of centuries of steady transformation. And unlike the natural climate cycles of the past, this one is driven by human hands. Already today, you can see the effects. Summers hotter than records from just decades ago, ice caps melting faster than predicted, storms growing stronger. These are the surface ripples. What lies underneath is the steady rise in greenhouse gases, trapping heat in the atmosphere. If you carry that pattern forward, not for 10 years or 50 years, but for hundreds of years, the world of the year 3000 begins to take shape. Scientists talk about tipping points. Imagine the Earth's systems like a seesaw. A little pressure one way or the other does not change much, but once you pass a certain balance, the whole system tips. Ice sheets in Greenland, for example, can survive small amounts of warming, but if the temperature rises too much, the ice begins to collapse. Once it starts, it is very hard to stop. That collapse pours fresh water into the oceans, raising sea levels, disrupting currents, and altering climates far beyond Greenland. By the year 3000, it is almost certain that today's ice sheets will be gone. Antarctica and Greenland, stripped of their ice, will expose bare rock, changing the shape of the planet itself. Now imagine the oceans. Rising seas are not just about coastlines slipping underwater, though that will happen too. Cities like Miami, Jakarta, and Dhaka already face flooding, and over centuries, whole regions may vanish beneath the waves. But more than land, it is the chemistry of the oceans that matters. As carbon dioxide dissolves in seawater, it turns the oceans more acidic, threatening corals, shellfish, and entire marine food webs. Corals, which today support vast ecosystems, may be gone by the year 3000. The oceans might still teem with life, but not the kind you know today. Instead of colorful reefs, there may be stretches of barren seabed, populated by new species adapted to warmer, more acidic waters. It may sound abstract, but think of it this way. In the year 1000, the North Sea supported immense populations of cod and herring, enough to feed empires. By the year 2000, those stocks were already collapsing from overfishing. Extend that decline another 1,000 years, layered with warmer seas and acidification, and the oceans of the year 3000 may not resemble food sources at all. They may be more like biological laboratories, filled with species engineered or managed by humans for survival. The land tells its own story. With rising temperatures come shifting rainfall patterns. Areas that are fertile today may become deserts tomorrow. Northern latitudes may become the new breadbaskets, while equatorial regions may turn too hot to sustain human life. Picture Siberia or northern Canada, lands of frozen soil in the year 2000. By the year 3000, they may be green plains, rich with agriculture. And the equatorial belt, from the Sahara across the Middle East to large parts of South Asia, may be harsh, dry zones where human survival without technology becomes nearly impossible. And yet, the most unsettling detail is not the heat itself, but its persistence. Once carbon dioxide is in the atmosphere, it lingers for centuries. The molecules released by your car or your home today could still be warming the planet in the year 3000. That means the Earth's climate carries a memory, a record of every action humanity takes. People of the far future will live not only with their own choices, but with the echoes of yours. It might help to picture examples from the past. When the Mayan civilization declined, centuries of drought played a role. Farmers abandoned fields that no longer yielded crops, cities emptied, and power shifted. When the Norse colonies in Greenland failed, it was not because of a single winter, but because of a long, slow decline in temperatures that made farming impossible. In both cases, climate shaped human history. By the year 3000, the same forces will still be at work, only amplified by human activity. Entire civilizations may rise or fall, depending on whether they can adapt to the new patterns of heat and rain. One of the dull but vital details is permafrost. In Siberia, Alaska, and northern Canada, soil has been frozen for tens of thousands of years, locking away ancient carbon. As the climate warms, that permafrost melts, releasing carbon dioxide and methane, are powerful greenhouse gases. This is another tipping point, a loop that feeds itself. The more the permafrost melts, the more gases are released, the warmer the planet becomes, and the more permafrost melts. By the year 3000, those frozen soils may be gone, replaced by wetlands or grasslands, and the gases they released will still be shaping the climate. The atmosphere itself will not look the same. Today, it carries the fingerprints of human industry. Soot, carbon, aerosols. In the future, it may also carry human attempts to fix what was broken. Some scientists already discuss geoengineering large-scale efforts to control climate. Imagine mirrors placed in space to reflect sunlight, or particles released high in the atmosphere to block heat. These ideas are controversial, risky, and untested, but by the year 3000, humanity may have no choice. The skies of the future may glow faintly with artificial particles, a permanent sign of human attempts to manage the climate. But then comes the deeper question: will humans still be here to see it? Rising temperatures do not necessarily erase humanity. People are adaptable. Air conditioning, advanced crops, migration, these tools can keep life going. But what climate change does is force change. Populations may shift northward, cities may be abandoned, food may be grown indoors or underground. The Earth itself will survive, but human life will be reorganized in ways that make today's borders, cultures, and cities feel temporary. You might wonder, will the Earth of the year 3000 even feel familiar? Perhaps not. Imagine stepping into a future where deserts stretch across what were once forests, where the poles are green and wet instead of icy, and where coastlines have been redrawn beyond recognition. Imagine seeing maps in the year 3000 continents looking the same in outline but carved with new bays, submerged cities, and artificial landscapes built to hold back the sea. And yet, there is a strange comfort here. The Earth has gone through cycles like this before. Millions of years ago, there were no ice caps at all. The poles were warm, covered in forests, and sea levels were far higher. Life survived then, just as it may survive in the future. The question is not whether life will go on, but whether humans, in their current form, will be part of that life. That brings us to a final reflection for this section. If the humans of the year 3000 live in controlled environments, dependent on artificial climates and engineered ecosystems, will they feel like they still belong to the Earth? Or will the planet itself feel like a place they visit, rather than a place they live? If you want to understand what the Earth will look like in the year 3000, you have to picture the ground beneath your feet, not as solid and still, but as something alive, always moving. It is easy to forget this, because on the scale of a human life, the land feels fixed. Mountains seem eternal, continents look unchanging on a map. But in truth, the Earth's crust floats on molten rock, broken into plates that drift slowly, a few centimeters each year. That motion, stretched over centuries, redraws the surface of the world. Think of it this way. If you stand in New York today and look across the Atlantic, the distance to Europe seems fixed. But the Atlantic Ocean is widening by a few centimeters each year as the American and Eurasian plates drift apart. Over 935 years, that is dozens of meters of change. Not enough to notice day by day, but enough to alter the exact shape of the ocean basin. At the same time, the Pacific Ocean is shrinking, pulled inward by the relentless grind of tectonic plates. The Pacific is sometimes called the Ring of Fire because of its volcanoes and earthquakes, and by the year 3000, those forces will continue carving coastlines and reshaping islands. Earthquakes are one of the immediate results of this slow motion. Cities today are built on fault lines that shift without warning. Los Angeles, Tokyo, Istanbul, these cities exist in places where tectonic plates grind against one another. In the year 3000, those fault lines will not have gone away. If anything, the cities built there may be gone, replaced by new ones, or perhaps those regions will be abandoned altogether if the quakes prove too frequent or destructive. The Earth does not care for the permanence of human buildings. It moves according to its own timetable. Mountains too are shaped by this invisible force. The Himalayas, formed by the collision of the Indian and Eurasian plates, are still rising today. Each year they grow by millimeters, but over centuries, that means they stretch taller, sharper, more rugged. By the year 3000, Everest and its neighbors will stand higher, though erosion may also wear away at their edges. The Alps, the Andes, the Rockies, all are the children of tectonic movement, and all will continue to shift. Imagine standing in a valley of the future, looking up at peaks even more jagged than today's, knowing they have been pushed upward by continents colliding like slow, unstoppable waves. Volcanoes are another reminder of this restless planet. In Iceland, Hawaii, Indonesia, and beyond, magma pushes upward through cracks in the crust, creating eruptions that can blanket skies with ash and change climates. Some eruptions in the past have been powerful enough to cool the Earth for years. The eruption of Mount Tambora in 1815, for example, caused what is called the year without a summer, when crops failed and people went hungry across the globe. By the year 3000, similar eruptions will occur again. Volcanoes are not events of the past. They are part of the Earth's breathing, and they will shape the lands of the future just as they shaped the lands of the past. And here is a quieter, stranger detail. The continents themselves are always rearranging. Millions of years ago, all the land was joined in a single supercontinent, Pangaea. Before that, there were other supercontinents, rising and breaking apart in cycles that stretch across hundreds of millions of years. In 1,000 years, the Earth will not yet have formed a new supercontinent, but the continents will have shifted noticeably. Africa continues to move north, colliding slowly with Europe. That collision may one day close the Mediterranean Sea. Australia drifts north toward Asia. North and South America creep westward. These are slow dances, but they never stop. By the year 3000, coastlines will not look quite like the maps you know today. Consider also the hidden world beneath the oceans. Mid-ocean ridges, vast underwater mountain chains, are places where new crust is born as plates pull apart. These ridges stretch for tens of thousands of kilometers, though few people ever see them. Over centuries, they create new seafloor, reshaping the deep ocean. At the same time, trenches like the Mariana Trench, mark places where crust is swallowed back into the earth. The planet recycles itself constantly. The land you stand on now may, in a distant future, be buried deep in the mantle, melted and remade. One of the dull but crucial consequences of plate tectonics is how it affects climate. The position of continents determines ocean currents, and ocean currents determine weather. For example, the closure of the Isthmus of Panama about 3 million years ago changed the flow of oceans and may have triggered the ice ages. In the year 3000, as continents continue to move, currents may shift again. That could mean new patterns of rainfall, storms, and temperatures slow but steady changes that ripple through ecosystems and civilizations alike. You might wonder, what does this mean for people? For one, it means cities may not last where they are today. Imagine Venice, already sinking as the Adriatic rises. In centuries to come, tectonic shifts and rising seas may erase it altogether. Imagine San Francisco, perched on the San Andreas Fault. By the year 3000, repeated earthquakes may have destroyed and rebuilt it many times, or driven people to abandon the region entirely. Even inland cities are not safe, as shifting rivers and mountain ranges can alter the resources that sustain them. But tectonics also create opportunity. The volcanic soils around Mount Vesuvius in Italy are famously fertile, supporting agriculture for thousands of years. Future eruptions elsewhere may bury lands in ash, but centuries later, those same lands may feed populations. It is a reminder that the Earth's destruction and creation are often the same process, seen at different timescales. One curious thought: in the year 3000, archaeologists of the future may dig through the ruins of today's cities, buried under layers of sediment or volcanic ash. Just as we uncover the remains of Pompeii, preserved by eruption, they may uncover the remains of our own world, frozen in rock. To them, our skyscrapers and highways may look as distant and strange as ancient fossils do to us. If you let yourself imagine standing on a coastline in the year 3000, the view may be unfamiliar, not because of human technology, but because the land itself has changed. Shorelines pushed inland, cliffs raised or eroded, new islands rising from volcanic activity. Perhaps entire mountain ranges that are small today will tower higher, while others may crumble away. It is a slow, dull process, centimeters of movement each year, but stretched across centuries. It is enough to rewrite the world. And so, the question becomes, when you imagine the future of humanity, do you imagine people adapting to these shifting lands, or abandoning Earth altogether for more stable ground beyond? When you think of Earth, you probably picture blue oceans covering more than 2/3 of the planet, shimmering ice at the poles, rivers cutting their way across continents. Water is what makes Earth different from every other world we know. And yet, if you carry time forward to the year 3000, the story of water becomes one of change, loss, and transformation. Oceans may swallow cities, ice may vanish, rivers may dry and then reappear in new places. The balance of water on Earth is not fixed. It shifts slowly, like a tide that lasts centuries. Start with the ice. In Greenland and Antarctica, thick sheets of frozen water hold enough to raise sea levels by dozens of meters. Already today, those sheets are melting faster than predicted. By the year 3000, it is difficult to imagine them surviving in anything like their present form. Greenland, a land whose name was once misleading because of its icy covering, may be green indeed. Bare rock, wet soil, rivers running where glaciers once lay. Antarctica, vast and cold even now, may lose its coastal ice shelves and see its interior exposed. These are not small changes. They are the kind that redraw maps. Every coastline on Earth would be rewritten if even part of this ice is lost. Consider what that means for cities. Today, the majority of the world's largest cities are coastal. New York, Shanghai, Mumbai, London, all of them depend on coastlines for trade, food, and culture. By the year 3000, rising seas may erase them. Not with a sudden wave, not like the scenes you see in movies, but with a slow, steady creeping of water. A few centimeters each year, a few meters each century. until streets that once bustled with traffic lie under shallow seas. Perhaps archaeologists of the future will dive through flooded skyscrapers the way we now explore shipwrecks. But rising seas are not the only story. As the climate warms, weather patterns shift, and water moves in unexpected ways. Some rivers will dry, their sources lost to melting glaciers. Others may flood more often, carrying unpredictable storms downstream. The great rivers of today, the Ganges, the Amazon, the Nile, may not look the same. The Amazon rainforest, often called the lungs of the planet, depends on its cycles of rainfall. If those patterns shift, parts of it could dry into savanna. The Nile, whose floods once gave life to ancient Egypt, may be reshaped by dams, droughts, or even the slow collision of continents. By the year 3000, the river that once sustained one of humanity's earlier civilizations may be unrecognizable. Oceans themselves are restless. Currents like the Gulf Stream carry warmth across the globe, stabilizing climates. But these currents depend on delicate balances of temperature and salinity. As ice melts and fresh water pours into the seas, those balances shift. Some scientists already warn that currents may weaken or even collapse, plunging parts of the world into colder climates while others heat up. Imagine Europe in the year 3000, perhaps colder than today despite global warming, because the Gulf Stream has faded. Imagine other regions, once temperate, now locked in drought. These are not sudden disasters but slow rebalancings, centuries in the making. And then there is the chemistry of the oceans. Already today, they absorb nearly a third of the carbon dioxide humanity releases. That keeps the air more breathable, but it makes the oceans more acidic. Shellfish struggle to form shells, corals bleach and die. By the year 3000, entire ecosystems may vanish from acidity alone. The oceans may still be full of life, but life that looks nothing like today's. Fish, as you know them, might be rare or extinct, replaced by new species adapted to harsher waters. Perhaps humans of the future, if they eat from the oceans at all, will farm engineered creatures designed to thrive where natural ones could not. Still, water has always been both destroyer and giver. Civilizations rose on the banks of rivers because rivers gave food, water, and trade. The Indus Valley, Mesopotamia, the Yellow River, each birthed cities and cultures that shaped history. But rivers also flooded, destroying crops, erasing towns. Oceans gave fish and salt, but also storms and shipwrecks. In the year 3000, the dual nature of water will remain. Entire societies may form around new rivers, new lakes, or even artificial water systems. Perhaps people will live inside domed cities where water is recycled endlessly, each drop used again and again. Or perhaps they will move into floating cities, drifting across oceans that swallowed the old coastlines. It helps to remember that Earth's water is ancient. The molecules in your glass of water tonight may be the same that once filled the seas of dinosaurs. Water cycles endlessly, from ocean to sky, to rain, to river, and back again. But the forms it takes, and the lives it sustains, change constantly. In the year 3000, the water cycle will still flow, but it may flow across a planet with very different landscapes, very different skies. One dull but essential detail is groundwater. Beneath the surface of the Earth lie vast reserves of water, locked in aquifers. Today, billions of people depend on them for drinking and farming. But in many places, those aquifers are being drained faster than they can be refilled. By the year 3000, many may be empty, replaced by dry rock. That could force future societies to rely on desalination, pulling fresh water from the oceans, or perhaps on technologies we cannot yet imagine. Water, which feels abundant now, may become the most carefully managed resource of all. And then there are icebergs and glaciers. In the year 1000, glaciers filled valleys across Europe and Asia. By the year 2000, many of them had already shrunk dramatically. By the year 3000, they may be gone entirely, leaving behind bare rock and empty basins. Those landscapes, once defined by ice, may hold lakes, forests, or deserts instead. Entire generations may live and die without ever seeing natural ice outside of a freezer or laboratory. Imagine, for a moment, standing in the year 3000 on what was once Antarctica. The air is cold, but no longer brutal. The land beneath your feet is rocky, perhaps covered with mosses, small plants, maybe even forests. Around you are rivers where glaciers once flowed. The ice is gone, but life has returned in a different form. For people of the year 3000, Antarctica might not be a frozen desert, but a new frontier of fertile land. And yet, for all these changes, the most haunting truth is that water always finds its way. You can build dams, you can pump rivers, you can desalinate oceans, but water is patient. It carves valleys, it wears down mountains, it swallows cities, it resurfaces in springs. By the year 3000, water will still be the master of Earth, even if humans have learned to bend it to their needs. So, here is the open thought to end on. If so much of the Earth we know is shaped by water, what happens to humanity if water itself becomes scarce, poisoned, or hidden deep below the surface? Take a slow breath. The air filling your lungs feels so ordinary that you hardly notice it. But that invisible mixture of gases is the single most important element keeping you alive from moment to moment. It is also one of the most fragile. By the time Earth reaches the year 3000, the atmosphere may not resemble the one you inhale today. Not in its composition, not in its clarity, not even in its ability to shield you from the sun. Start with the basics. Air is mostly nitrogen, with a smaller fraction of oxygen and a scattering of other gases. That balance has not always been the same. Billions of years ago, Earth's air had no oxygen at all, only volcanic fumes and carbon dioxide. Then, photosynthetic organisms filled the skies with oxygen, creating the conditions for animals and humans to exist. The point here is simple but sobering. The air has changed before, and it can change again. Already, you live in an atmosphere with more carbon dioxide than at any time in at least the last 800,000 years. The greenhouse effect, which makes Earth warm and livable in the first place, becomes more intense as those gases rise. By the year 3000, if emissions continue or even partly stabilize, carbon dioxide levels could remain much higher than today. That means a warmer Earth, yes, but also a different chemistry in the air itself. It is not just temperature, it is the way you breathe, the way plants grow, the way oceans absorb carbon. There is also ozone, the thin, invisible layer that protects you from ultraviolet radiation. In the 20th century, human activity tore holes in that shield, especially above Antarctica. International cooperation phased out the worst chemicals, and the ozone layer has slowly been healing. But by the year 3000, its fate depends entirely on whether humanity repeats old mistakes or avoids them. If ozone weakens again, more radiation would reach the ground, making outdoor life more dangerous, increasing cancers, damaging crops. If it strengthens, Earth might enjoy a more stable protective screen than at any point in modern memory. But the air is not just a protective layer, it is a carrier of life and of poison. Think of smog in industrial cities, of wildfires that fill skies with smoke, of volcanic eruptions that spread ash across continents. In the year 3000, these events may be more common, not less. If forests burn more frequently in a hotter climate, smoke may become a regular feature of the atmosphere. If volcanoes erupt, and geologically they always will, the ash can cool the planet for years, even centuries, at a time. So while carbon pushes Earth to warm, natural events may sometimes pull it suddenly cooler. Future humans may live not with a single climate, but with sharp swings driven by the chemistry of air. One detail that may sound dull but is vital: aerosols. Tiny particles suspended in the air, often from pollution or natural dust. They reflect sunlight, they seed clouds, they influence rainfall. In modern times, industrial aerosols have actually cooled Earth slightly, masking some of the warming from greenhouse gases. By the year 3000, if industrial activity has shifted or declined, that masking effect may fade. letting the full force of warming appear. It is not a dramatic story like rising seas, but it is the kind of slow, almost invisible factor that shapes entire centuries. Air quality is another dimension. Today, billions of people breathe polluted air daily. That damages lungs, shortens lives, and burdens societies. Imagine the air of the year 3000. Perhaps humanity has solved pollution through clean technology, and every breath is pure. Or perhaps cities are domed, sealed from the outside, with artificial air pumped and filtered. In that case, the atmosphere outside may be thick, hazy, and toxic, while the air inside cities is tightly controlled. Air could become a resource, something managed, sold, or even rationed. History gives us examples. In ancient Rome, the air was thick with smoke from wood fires. In 19th century London, coal soot turned the skies black. In 20th century Los Angeles, smog became a daily burden. Each of those societies lived with air that was far from clean, yet people adapted until technology and policy shifted. By the year 3000, will adaptation mean learning to survive in toxic air, or will it mean creating technologies that return the atmosphere to a cleaner state? The role of the atmosphere goes beyond human health. It shapes sound, color, and even the way you see the stars. A thicker, dustier atmosphere might make sunsets more red, skies more orange, stars dimmer at night. A thinner or cleaner atmosphere might make the sky almost unnaturally clear, with stars sharp enough to seem close. These details may sound small, but they affect the way people feel and imagine their place in the universe. There is also the possibility of deliberate change. Humans already discuss geoengineering large-scale attempts to alter the atmosphere to cool the planet, spraying reflective particles into the sky, seeding clouds, or even building giant mirrors in space. If such techniques become reality, the atmosphere of the year 3000 might not be natural at all, but carefully managed. Each sunrise and sunset could be the product of human design, not just physics. Imagine living under a sky that you know was engineered by your ancestors centuries earlier. But even if humanity manages air perfectly, the atmosphere itself changes on geologic timescales. Earth slowly loses gases to space. The sun grows hotter, altering the balance. Over millions of years, those changes matter deeply. By the year 3000, they are subtle but not absent. The atmosphere is thinner than it was in the year 1000, and will be thinner still in the year 5000. What seems eternal is in fact temporary. Let us imagine, for a moment, standing in the year 3000 and breathing. Perhaps you wear no mask, the air is clean, the sky brilliant blue. Perhaps you wear a filter because particles hang thick in the air, or oxygen levels are lower than your body can comfortably handle. Perhaps the air is fine, but you live beneath a dome anyway, because society no longer trusts the atmosphere to remain stable. Each of these scenarios is possible, depending on choices made not in the year 2900 or 2990, but right now. And there is another thought. Air connects everyone. You breathe the same molecules that once passed through a medieval farmer, through a Roman emperor, through a dinosaur. Carbon from an ancient forest may leave a car exhaust today and settle into a lung across the globe tomorrow. Air is the most democratic of Earth's resources, shared, exchanged, impossible to own. By the year 3000, that truth will not change. The air may be warmer, dirtier, thinner, or engineered, but it will still be shared by every living thing that breathes. So here is the unresolved thought. If air is both the most fragile and the most shared part of Earth, how will future humans decide who controls it, who manages it, and who takes responsibility when it begins to change? Close your eyes for a moment and picture the living Earth as it is today. Vast forests, grasslands, oceans, coral reefs, deserts, tundra, and every imaginable niche between them. Millions of species, many undiscovered, all weaving together into a single web of life. Now imagine fast-forwarding nearly 1,000 years. How much of this richness will remain? Will you still hear the songs of birds, the buzzing of bees, the rustle of leaves in forests, or will silence creep across the planet? The loss of biodiversity is already one of the defining features of your own time. Scientists estimate that species are disappearing at rates hundreds of times faster than the natural background pace. By the year 3000, the outcome of this ongoing crisis may shape the very look and feel of the planet. Extinction is permanent. Once a species is gone, it does not return. That is why the question of biodiversity is not about temporary inconvenience, but about what kind of living Earth future generations inherit. Think of the bees. These small, ordinary insects are pollinators, vital to crops and wild plants. Without them, entire food webs unravel. Imagine a future where pollinators are scarce. Perhaps robots take their place, buzzing through orchards to spread pollen. Perhaps genetic engineering creates new, resilient pollinators. Or perhaps the old bees survive after all, adapting to changing climates. Each possibility leads to a different Earth. Forests are another pillar. Rainforests, like the Amazon, are sometimes called the lungs of the planet, absorbing carbon and hosting vast biodiversity. Already, deforestation has carved away enormous portions of these ecosystems. By the year 3000, they could be reduced to fragmented patches, managed like zoos of trees rather than wild expanses. Or, with reforestation and restoration, they might expand again, perhaps even in new regions where the climate becomes wetter. The question is not only how much forest remains, but what kind of forest it will be. A wild, self-sustaining system, or a carefully managed plantation designed by humans. The oceans hold even more uncertainty. Coral reefs, those dazzling underwater cities, are bleaching and dying as waters warm and acidify. If current trends continue, reefs may vanish within centuries. By the year 3000, that could mean oceans emptied of their most complex habitats. Fish populations might collapse, leaving seas far less diverse. Or, again, technology may intervene. Artificial reefs, genetically engineered corals resistant to heat, or entirely new marine ecosystems seeded by human design. The ocean of the future may be less about what nature created and more about what humans chose to preserve. History offers sobering lessons. When humans arrived in Australia tens of thousands of years ago, many giant marsupials vanished. When humans reached the Americas, mammoths and saber-toothed cats disappeared. When European settlers spread across islands, countless birds went extinct. The pattern is clear. Wherever humans expand, large animals often vanish. By the year 3000, will lions, elephants, whales, and tigers still exist? Or will they be remembered only in digital archives and genetic samples? Extinction does not mean emptiness, though. Ecosystems reorganize, new species emerge. Already, urban environments host their own unique ecologies: pigeons, rats, cockroaches, weeds that thrive in cracks of concrete. By the year 3000, there may be an entirely new suite of species evolved to live alongside humans in cities, factories, and artificial habitats. Biodiversity will not vanish, but it may look nothing like what you recognize today. A curious question arises here. Will humans choose to bring back lost species? With advances in genetics, some scientists already attempt to revive extinct animals like the woolly mammoth. By the year 3000, such de-extinction could be common. Zoos might contain creatures that disappeared thousands of years ago, or wild landscapes might be repopulated with reconstructed species. But this raises a subtle point. A revived mammoth is not the same as the original mammoth. It is a human-made approximation. The living world of the year 3000 might be a patchwork of natural survivors and artificial recreations. Plants are part of this story too. Crops may be entirely different by then. Today, humans rely heavily on just a handful of plants: rice, wheat, maize, soy. By the year 3000, those plants may be so genetically modified that they are unrecognizable. They may grow in deserts, in salt water, or even under artificial lights in underground farms. Wild plants, meanwhile, may retreat into reserves or vanish under pressure from climate change. Imagine a world where the fields are full of crops designed by humans, while wildflowers and native plants are remembered only in museums of seeds. The role of humans as gardeners of Earth is inescapable. Already, national parks, wildlife reserves, and seed banks act as vaults for biodiversity. By the year 3000, that approach may extend planet-wide. Entire continents might be designated as preserves, while other areas are entirely given over to human use. Biodiversity would survive, but only as carefully curated exhibits. The distinction between wild and managed may blur until it disappears altogether. There is also the possibility of collapse. If ecosystems unravel faster than technology can intervene, the year 3000 could see deserts expand, forests shrink, oceans decline, and biodiversity fall to a fraction of its current level. Life would persist, as it always has, but in forms far simpler, less varied, less colourful. A quieter, emptier Earth. That is one path, though not the only one. On the other hand, some scientists imagine a flourishing. If humanity stabilizes climate, protects ecosystems, and restores lost habitats, the year 3000 might see greater biodiversity than today. Species could adapt and evolve into new forms, filling niches created by change. Cities could host green corridors, vertical forests, and rooftop ecosystems. Oceans could teem with engineered reefs and new marine life. Earth would still be different, but rich in life once more. Here is a small but telling detail. Seed banks. Around the world today, vaults preserve seeds of thousands of plants in case of catastrophe. By the year 3000, those seed vaults might be humanity's greatest treasure, repositories of genetic diversity that can restore entire ecosystems. A dull detail, perhaps frozen seeds locked in underground vaults, but one with enormous consequences, quiet, boring, and essential. There is also the unknown. Evolution continues whether humans interfere or not. New species are born in every age. Insects, microbes, and plants evolve quickly. By the year 3000, entirely new species will exist, filling niches we cannot predict. Some may be pests, others may be keystone species that sustain ecosystems. The story of biodiversity is not only about loss, but about change, unpredictable, uncontrollable, ongoing. So when you imagine Earth in the year 3000, you must hold two pictures at once. One is bleak, forests gone, oceans depleted, animals extinct, silence replacing song. The other is hopeful, restored ecosystems, thriving biodiversity, and even new species brought forth by both evolution and human creativity. The truth may lie somewhere between, shaped by choices you and your descendants make. And here is the unresolved question. In the year 3000, will humans see themselves as stewards of life, protecting and nurturing it, or as engineers, designing and recreating it? And will the rest of Earth's species still live alongside us as equals, or as exhibits in a human-shaped world? Think of how much your life depends on technology today. You wake up to alarms on digital devices. You travel in vehicles powered by engines or electricity. You rely on global networks of satellites to navigate and to communicate. All of this has arisen in just a few centuries. Now imagine stretching forward almost 1,000 years. By the year 3000, technology will not just shape life, it may define what it even means to be human. Start with the most basic layer, energy. Today, your world is in transition, moving away from fossil fuels toward renewable sources. In 1,000 years, that transition will be complete. Solar power may dominate, collected not only on Earth but also in orbit, where vast mirrors capture sunlight and beam it down. Fusion power, the same process that fuels stars, may finally become routine, offering nearly limitless energy from simple hydrogen. It is not a dramatic image, a quiet hum of power plants, the dull glow of infrastructure, but it is the foundation for everything else. Energy abundance changes what humans can build, how they live, and where they go. Then think of cities. Already, some cities tower with skyscrapers, sprawl with endless suburbs, or sink into underground transit tunnels. By the year 3000, cities may be vertical ecosystems, with farms, homes, and workplaces stacked into self-contained structures. Transportation could be largely invisible, silent pods moving on magnetic tracks, drones delivering goods, underground corridors for heavy traffic. To you, the listener, that might sound exciting, but in daily life it might feel mundane, just as smartphones do today. Imagine a child in the year 3000 yawning as they use a teleportation booth to move from one district to another. What feels miraculous to you now could be ordinary to them. Technology also extends into the body. Even now, medical science allows organ transplants, prosthetics, and gene editing. Push forward 1,000 years, and bodies might be fully customizable. Genetic modification could remove hereditary diseases. Cybernetic implants could extend senses beyond natural limits, letting you hear frequencies that only animals once heard, or see infrared light. Memory could be stored externally, backed up like a hard drive. The boundary between human and machine might blur so much that the very definition of you becomes complicated. This raises a subtle question. If you can replace every part of your body, even your brain, with artificial components, while keeping your memories intact, are you still you? It is not a question science alone can answer, but it becomes practical in a world where such replacement is possible. Communication is another point. Already, the internet connects billions instantly. By the year 3000, communication may bypass screens and voices altogether. Direct neural links could allow people to share thoughts or emotions as effortlessly as words today. Instead of saying, "I feel tired," you might transmit the exact sensation of fatigue. Instead of describing a landscape, you could project it directly into another person's mind. This changes not only how people interact, but what privacy means. If thoughts can be shared, can they also be stolen? Transportation extends beyond Earth. Humans may live in colonies on Mars, on moons of Jupiter, or on artificial habitats orbiting the Sun. These would not be glamorous sci-fi visions, but rather practical, lived-in environments, metal walls, hydroponic farms, recycling systems, details that sound boring but keep people alive. Perhaps humans in the year 3000 will look back at Earth as their ancestral home, but no longer their sole home. And perhaps their daily life in space will feel just as routine as farming once felt to their distant ancestors. Another quiet but crucial technology is automation. Already, machines build cars, harvest crops, and handle logistics. In the future, entire economies might be run by artificial intelligence, with humans only making broad decisions. Imagine factories that run without pause, farms that adjust automatically to weather, and transport systems that reroute themselves without human drivers. To you today, this may seem extraordinary, but to the people of that era, it might feel as dull as electricity does to you. It is simply there, humming in the background, unnoticed, until it stops. And then there is the possibility of virtual existence. Even today, people spend hours in digital environments. By the year 3000, entire lives could be lived inside simulations indistinguishable from reality. Some may choose to live primarily in these spaces, creating worlds of their own design. Others may reject them, preferring the physical world. This creates two parallel existences, one of flesh and matter, another of code and perception. Which one counts as more real? Historical perspective helps here. When the printing press appeared in the 15th century, it transformed knowledge. When electricity spread in the 19th century, it altered life in countless small ways. When the internet arrived in the 20th century, it rewired communication. Each step seemed enormous at the time, yet soon became invisible, absorbed into normal life. The same may happen with the technologies of the year 3000. They may feel overwhelming to you now, but to those who lived then, they may feel ordinary, even boring. What about inequality? Technology tends to spread unevenly. Even today, not everyone has access to clean water, let alone advanced medicine. In the year 3000, some humans may live with incredible enhancements, while others remain closer to the biological baseline. Entire classes of society may emerge: the modified and the unmodified, the connected and the disconnected. History suggests that access to technology often defines power, so the distribution of these tools may shape human culture as much as the tools themselves. There is also the possibility of decline. Technologies can be lost. Ancient Rome had complex aqueducts and concrete formulas that vanished for centuries. If a future catastrophe disrupted global infrastructure, much of this advanced technology could fade. The year 3000 might not be a world of gleaming towers, but one of scattered remnants, where survivors remember that once things were different. Yet even in decline, technology leaves traces. Broken satellites in orbit, decayed data centers, forgotten machines rusting in fields, the archaeology of the future. Just as you uncover fragments of past civilizations today, people in the year 3000 might dig through ruins of servers and skyscrapers, piecing together the life of the 21st century. So, when you imagine technology in the year 3000, picture not only the dazzling frontiers, but also the mundane infrastructure, the inequalities, the risks of collapse, and the quiet persistence of machines. The question is not whether technology will change, it always does, but how humans will choose to live with it. And here is the open thought to leave you with. By the year 3000, will technology still feel like something separate, an invention used by humans? Or will it merge so fully with human life that it simply becomes the background, as natural and unnoticed as air and water are today? When you think about the year 3000, technology often comes first to mind. Yet culture, the beliefs, traditions, languages, and values that humans share may shift just as deeply. In many ways, culture is the invisible framework that guides how people live. It tells you how to greet a neighbor, how to celebrate, how to mourn, and what counts as important. If you extend human history forward by almost 1,000 years, it becomes clear that culture may change in ways just as significant as machines or science. Start with language. 1,000 years ago, English as you know it today barely existed. The words were different, the grammar unfamiliar, the sounds harsh and strange to your ear. 1,000 years from now, English may also be unrecognizable, or perhaps even gone. New languages could evolve, blending today's tongues into hybrids. Or perhaps translation technology will make language barriers vanish, creating a kind of global speech that is constantly shifting, never fixed. Imagine someone in the year 3000 speaking in phrases that feel both familiar and alien to you, just as Old English feels today. Religions and spiritual beliefs may also shift. Throughout history, old gods have faded while new faiths emerged. In the year 3000, the major religions of today may still exist, adapted to new times, or they may have merged into new systems of meaning. It is possible that spirituality will move away from traditional texts and rituals, focusing instead on direct experience, perhaps aided by technology, shared visions, neural experiences, or even simulations designed to explore the idea of the divine. But it is just as possible that humans will cling to ancient traditions, repeating prayers and rituals that have been spoken for thousands of years. Both possibilities can coexist, as they often do, across cultures. Art also evolves. Think of how music changed from medieval chants to modern electronic sounds. Think of how painting went from cave walls to digital screens. By the year 3000, art may be immersive, not simply observed. You might not just listen to a symphony, you could step into it, feeling the notes vibrate through your body, seeing them as colors in the air. Stories could unfold not on paper, but in fully interactive worlds, where you are both audience and participant. Yet even with these changes, the essence of art remains. It is humans trying to express what they feel, to share the inner experience of being alive. Now consider traditions. Today, you celebrate birthdays, holidays, or national events. In the year 3000, these traditions may vanish, replaced by new markers of time. If humans live much longer lives, perhaps hundreds of years, birthdays may lose their meaning. Imagine celebrating your 100th and 50th birthday as casually as someone today celebrates their 30th. Or perhaps traditions will form around technology, a yearly remembrance of the first human landing on Mars, or rituals marking the upload of someone's consciousness into digital form. Culture adapts to what feels significant in its own time. Family structures also shift. In earlier centuries, families were often large, with many children, all working together for survival. Today, families are smaller, often shaped by economics and social expectation. By the year 3000, family could mean something entirely different. If human lifespans extend dramatically, generations may overlap in strange ways. Imagine meeting your great-great-great-grandparent who is still alive. Or family may no longer be biological at all, but chosen, formed through bonds of shared experience in both physical and digital worlds. And then there is governance and identity. Today, you live within nations, defined by borders and governments. But 1,000 years is a long time. Nations may fade, replaced by planetary governance, or even interplanetary councils if humans spread to other worlds. Identity might no longer be tied to country but to community, to network, or to ideology. Instead of saying, "I am from Canada," or "I am from Japan," someone in the year 3000 might say, "I am part of this knowledge collective," or "I belong to this cultural stream." The frameworks of belonging shift with the scale of human life, but culture also has a way of preserving the past. Even as new traditions arise, old ones linger. A holiday celebrated for 1,000 years might still be celebrated in another 1,000. A poem written centuries ago may still be read. Just as you today still study ancient Greek tragedies or medieval epics, people in the year 3000 may still turn back to Shakespeare, or even to writers who are alive in your own time. Culture carries memory forward, sometimes changing it, sometimes preserving it almost untouched. This raises another thought. Will humans in the year 3000 see themselves as connected to you, as part of the same story? Or will they see you as impossibly distant, like you see cave dwellers carving figures into stone walls? The connection of culture is fragile. It depends on what is remembered, what is passed on, and what is forgotten. Think, too, of leisure and entertainment. Even today, leisure defines much of culture. Watching films, playing games, listening to music, gathering with friends. In the year 3000, leisure may be deeply immersive, with people entering shared simulations or crafting experiences indistinguishable from dreams. Yet at its heart, leisure still fills the same need it always has to rest, to connect, to imagine something beyond daily survival. The details change, the essence remains. Finally, culture is shaped by memory, both individual and collective. What stories will humans in the year 3000 tell about your era? Will they remember climate change, pandemics, and wars? Or will they tell of your age as a time of beginnings, the dawn of space travel, the rise of digital networks, the early experiments with genetic science? Perhaps they will tell both kinds of stories. Culture is not just what you create now, but also how the future chooses to remember you. So when you picture the year 3000, do not just think of the machines or the science. Picture the voices, the songs, the rituals, the quiet habits of daily life. They may look unfamiliar, but they will still serve the same purpose they always have: to give humans a sense of meaning and belonging. And here is the thought to leave you with. If culture is always shifting, always blending old and new, then, in the year 3000, will humans still feel connected to their ancestors? Or will the distance be so great that they see themselves as something entirely new, no longer bound to the past at all? When you imagine Earth in the year 3000, it is easy to think only of cities, technology, and human culture. Yet the environment itself, the oceans, the forests, the ice caps, the deserts, will continue its slow, relentless transformations. largely indifferent to human concerns. Stretching nearly 1,000 years into the future, these changes become both subtle and profound, shaping the very canvas on which life unfolds. Start with the oceans. Even today, they are shifting, warming, acidifying, rising. By the year 3000, the effects of centuries of greenhouse gases, combined with natural cycles, will have reshaped coastlines and currents. Rising seas may have swallowed large portions of land that are bustling cities today. New shallow seas may have formed in low-lying areas. Archipelagos could emerge from underwater volcanoes. The very floor of the ocean continues to move with tectonics, creating mountains, trenches, and basins in ways that are invisible on human timescales, but monumental over centuries. The chemistry of the seas will also change. Acidification from carbon absorption may reach levels difficult for many current marine species to survive. Coral reefs, if still present, might be replaced by hardier, artificially assisted versions or entirely new ecosystems that have evolved to thrive under altered conditions. Fish populations, already stressed today, may have shifted patterns, with some species migrating closer to poles or disappearing entirely. The ocean of the year 3000 may feel alien to someone from the 21st century, yet life will persist in forms adapted to this changed world. Ice caps and glaciers tell another quiet but dramatic story. Greenland and Antarctica will not remain as they are today. The polar ice may have retreated significantly, exposing new land to colonization by plants and animals. Sea ice in the Arctic will continue to fluctuate with warming trends, altering not just local ecosystems but global climate patterns through feedback loops. Rivers once frozen by glaciers may flow continuously, carving new valleys and changing landscapes in ways that seem slow in daily life but massive across centuries. Forests, too, will shift. Climate change, human activity, and natural processes will create new patterns. The Amazon may shrink, or parts of it may regrow if rainfall patterns stabilize. Boreal forests could advance northward, following colder species, while deserts expand where rainfall fails. Human intervention reforestation, protection of habitats, or creation of artificial forests may further alter these patterns. The landscapes of forests will be less random and more curated, a mix of natural evolution and intentional design. Deserts and arid regions will evolve as well. Expanding deserts may swallow parts of Africa, the Middle East, and Central Asia as temperatures rise and rainfall diminishes. Yet these regions are not lifeless. Life adapts. Plants and animals evolve to conserve water, to survive extremes, and to exploit microhabitats. Human settlements may also adapt, with cities designed for extreme temperatures, underground farms, or floating settlements along desert rivers. The environment will shape survival, but it will not end it. Air currents and climate patterns will also be markedly different. The slow shifts of the Earth's tilt, combined with human-influenced warming, may alter monsoons, hurricanes, and wind patterns. Storms could strike regions not historically accustomed to them. Seasonal rainfall may change in intensity and timing. Some areas may experience longer droughts, others intense flooding. For humans and animals alike, adaptation to these shifting patterns will be essential. What seems ordinary today, summer rains, winter storms may become rare or extreme events. Consider freshwater systems, rivers, lakes, and aquifers. Glacial meltwater will have redirected flows, creating new lakes and drying others. Rivers may carve entirely new paths as rainfall patterns shift and land erodes. Groundwater, already overused in many areas today, may be managed carefully or even artificially replenished through human intervention. Access to fresh water will remain a determining factor for where civilizations thrive or fail. Oceans, ice, and forests do not act in isolation. Changes in one system ripple through others. Melting ice alters ocean salinity, which shifts currents, which changes climate patterns, which affects forest growth, which in turn affects carbon absorption and rainfall. This interconnectedness means that small changes today can become major differences by the year 3000. The environment of that era will be the result of countless tiny forces acting together over centuries. One dull but crucial detail is soil. Soil is often overlooked, yet it forms the foundation of life. Erosion, nutrient depletion, and climate changes will alter soil composition across the globe. Some areas may become richer due to deposition of silt and organic matter, while others may turn barren. Agriculture, forests, and natural vegetation will depend on these subtle shifts. A millimeter of soil lost per year seems trivial, but over centuries, it can reshape the land humans depend on. Sea levels, ice, and storms also interact with human infrastructure. Cities built near coasts may have been abandoned, relocated, or transformed into floating habitats. Bridges, ports, and roads may be buried, re-engineered, or forgotten entirely. The environment itself will rewrite the map of human habitation, leaving only traces of past civilizations in sediment, ruins, and underwater relics. Wildlife will respond to these environmental changes, migrating, evolving, or disappearing. Species that survive will be those that can adapt quickly, reproduce effectively, and exploit new habitats. Those that cannot will vanish, leaving gaps in ecosystems that may be filled by new forms, some entirely engineered by humans, others naturally evolved. By the year 3000, the living landscape may be unrecognizable yet deeply adapted to the environmental pressures that have unfolded over centuries. And yet, even with these vast shifts, the Earth retains continuity. Oceans still rise and fall, ice still forms and melts, rivers still carve valleys, winds still shape dunes, and forests still grow. Life persists. The changes may be invisible day to day, but when measured across centuries, the transformations are enormous. By the year 3000, Earth may be warmer, greener in some places, drier in others, and filled with species adapted to these new realities. So here is the open-ended question. When you picture the year 3000, is Earth still the familiar blue and green planet you know, or is it something stranger, shaped by forces you cannot see, yet full of life that endures in ways you could never predict? Close your eyes for a moment and imagine the year 3000. Nearly 1,000 years have passed since today. Humans, if they still exist, will be the product of countless choices, adaptations, and innovations. But will you, or your distant descendants, still walk the same Earth we know? Will humans be a dominant species, or something different entirely? Start with population dynamics. Today, humans are nearly 8 billion, concentrated in cities, fertile river valleys, and coastal plains. By the year 3000, the number of people will depend on countless factors: fertility rates, resource availability, climate change, disease, and technology. Populations may stabilize, decline, or shift dramatically. Some regions may be nearly empty, deserts, or flooded lands pushing communities towards safer areas. Other regions may thrive, particularly where technology allows people to control their environment. Food will be a central determinant of survival. Agriculture today is global, dependent on predictable climate, fertile soil, and access to water. By the year 3000, climate shifts may make traditional farming regions untenable. Humans may adapt through vertical farming, hydroponics, or even lab-grown meat. Crops may be genetically engineered to survive in harsher conditions, withstand drought, or grow in artificial light. Humans may no longer depend on natural ecosystems to sustain themselves, but on carefully controlled systems that mimic nature while extending life. Health and longevity are another crucial factor. Today, medicine has extended lifespans considerably, but diseases, pandemics, and malnutrition still threaten millions. By the year 3000, medicine may have advanced to the point that most infectious diseases are controlled or eradicated, and genetic disorders corrected before birth. Life expectancy could reach centuries, radically altering social structures, careers, family dynamics, and culture. Yet this longevity comes with responsibility. Resources must be managed sustainably to support long-lived populations. Human adaptation will also involve physical and cognitive change. Genetic engineering could allow humans to tolerate extreme climates, resist diseases, or even enhance cognitive abilities. Cybernetic enhancements may become common, blurring the line between biological and artificial. Memory, perception, and communication may be augmented through technology, making human experience fundamentally different from your own. Imagine humans capable of surviving extreme cold without clothing, or of living underwater in specially engineered suits. The species may become more diverse than you can currently imagine. Space colonization is another survival pathway. Humans may no longer be bound to Earth. Mars, the Moon, or artificial habitats in orbit may host permanent populations. These communities will face extreme challenges: lower gravity, radiation exposure, limited natural resources. Yet humans are adaptable. Over centuries, people may evolve biologically or technologically to thrive in these environments. The year 3000 may see humans who no longer identify primarily with Earth, but with a habitat that is entirely artificial, floating in space. But survival is not guaranteed. Environmental collapse, resource depletion, or catastrophic events could reduce human populations dramatically. Volcanoes, asteroid impacts, pandemics, or climate tipping points may push humanity to the brink. Small, isolated groups may endure in carefully chosen refuges, much like how early humans survived ice ages. The question is not just whether humans survive, but how they adapt to a world that has been reshaped in every conceivable way. Social organization will be critical. Today, humans live in nations, cities, and communities, governed by laws, norms, and institutions. By the year 3000, these structures may evolve. Perhaps humanity will live under global governance, coordinating resource use, technology, and migration to survive climate and environmental changes. Perhaps local communities will become self-sufficient, relying on closed ecosystems to maintain life. These social adaptations are as vital as technological or biological ones. Survival depends not only on bodies and tools, but on trust, cooperation, and governance. Culture will influence survival as well. Beliefs, traditions, and shared values shape how humans respond to challenges. In the year 3000, societies that adapt culturally, valuing sustainability, scientific knowledge, and cooperation may thrive. Those that cling to outdated practices may fail, no matter how technologically advanced they are. Culture is the invisible infrastructure of adaptation, guiding decisions long before technology is applied. Energy and resource management remain central. Today, humans rely on fossil fuels, solar power, and other resources. By the year 3000, energy scarcity could threaten survival if technologies fail or are mismanaged. Fusion power, solar arrays, and orbital energy collection may provide near limitless supply, but infrastructure must be maintained. Fresh water, food, and raw materials must also be managed carefully. Survival at this scale is not just a biological problem. It is a question of engineering, logistics, and foresight. One quiet but vital detail is redundancy. Life persists through backup systems, seed banks, genetic archives, energy storage, emergency reserves. By the year 3000, humanity may have created layers of redundancy for survival. If a crop fails, if a water source dries, or if a habitat is threatened, alternative systems may prevent collapse. These details seem boring, but they are what allows civilizations to endure across centuries. Without them, a single disaster could erase entire populations. Disease remains a subtle threat. Even with advanced medicine, viruses and bacteria evolve rapidly. In a world of global travel or interconnected habitats, pandemics may arise unpredictably. By the year 3000, humans may have developed adaptive medicines or preventive systems that monitor and respond instantly. But the constant interplay between evolution and human adaptation means that survival is never guaranteed, it is always negotiated. Human adaptation will also shape the environment. Cities, farms, forests, and artificial habitats may all be engineered to optimize human survival. Yet every intervention changes the world. By the year 3000, Earth may bear little resemblance to the planet you know today, not because humans have destroyed it entirely, but because survival requires shaping it to human needs. Ecosystems, water systems, and even the atmosphere may be co-managed, partially natural, partially engineered. And yet, even with all these changes, humans remain vulnerable. Catastrophe, mismanagement, or unforeseen events could dramatically reduce populations. History is full of civilizations that vanished despite technology and ingenuity. Survival is never guaranteed. It is always contingent. The year 3000 may see humans thriving, dispersed across planets, enhanced biologically and technologically, or it may see small populations eking out existence in carefully maintained refuges. So here is the open-ended thought. If humans endure until the year 3000, will they still feel fundamentally the same as you do today? Or will adaptation, biological, technological, cultural have made them something entirely different, perhaps unrecognizable as the species you call human? And if humans vanish, what traces of them will remain on Earth, in oceans, forests, cities, and the very air you breathe? Close your eyes and imagine looking up at the night sky in the year 3000. The stars will shine as they always have, but for some humans, they may no longer be distant points of light. They may be homes. Space exploration is already part of human history today, but by the year 3000, it may become an integral part of human survival and culture. Life beyond Earth could redefine what it means to be human. Start with colonies. Humans may inhabit Mars, the Moon, moons of Jupiter or Saturn, or artificial habitats orbiting the Sun. These environments are extreme thin, or no atmosphere, radiation exposure, low gravity, and scarce natural resources. Survival in such places requires technological mastery, careful planning, and adaptation. Over centuries, humans may not only survive but thrive. Genetic engineering could produce humans adapted to low gravity or higher radiation tolerance. Cybernetic enhancements may allow living in conditions previously impossible. Habitats might be entirely sealed, self-sustaining ecosystems, carefully maintained by AI systems. Distance from Earth adds another layer of complexity. Communication across space is limited by the speed of light. Messages between planets may take minutes, hours, or even days. By the year 3000, humans living off-world may develop distinct societies, languages, and cultures, shaped by their unique environments. Imagine a Martian community with traditions, holidays, and governance entirely distinct from Earth, yet still aware, through delayed communication, of the planet humans once called home. Space survival will also redefine energy use. While Earth relies on sunlight, wind, and fossil fuels, orbital colonies or settlements on moons may harness solar energy more efficiently, or even capture energy directly from fusion reactors in space. Water and air must be recycled almost perfectly, creating a closed-loop system where every molecule matters. These constraints may make humans living in space extraordinarily efficient, cautious, and inventive, a level of environmental discipline that could seem alien to an Earth-bound observer. Consider resources. Asteroids may be mined for metals and minerals, ice may be extracted from distant moons for water, and energy may be collected in orbit to power habitats both in space and on Earth. Human ingenuity will transform what was once unreachable into essential commodities. Even mundane details, like how oxygen is stored, recycled, or shared in a colony, could determine whether entire populations survive. Space is not a glamorous frontier in this context. It is a careful negotiation with physics, chemistry, and biology. Extraterrestrial influence is also a consideration. While we have no verified contact with alien civilizations today, by the year 3000, possibilities emerge. Humans may encounter microbial life on Mars, oceans beneath the ice of Europa, or evidence of past civilizations elsewhere. Such discoveries could reshape culture, philosophy, and science, even if contact is never direct. The simple fact that life might exist elsewhere would influence human perception of themselves and their place in the cosmos. Space also challenges human psychology. Isolation, limited social networks, and confined habitats can create stress. By the year 3000, humans may have adapted culturally and biologically to these pressures. Virtual environments could supplement social life, and AI companions may serve as constant interaction partners. Generations may grow up entirely in space, never setting foot on Earth, developing norms and social structures that are entirely alien to modern humans. History offers lessons in adaptation. Early Earth explorers, astronauts, and even isolated island populations show that humans can adjust to extreme conditions. Yet space is orders of magnitude more challenging. Every survival choice is deliberate. The temperature you allow in your habitat, the food you ration, the energy you expend. By the year 3000, these choices may be second nature to people living in space, yet invisible to those on Earth. Habitats will be carefully maintained, life prolonged, and every resource recycled in ways that seem mundane but are critical. Colonies may also influence Earth. Materials mined from asteroids, water extracted from moons, or energy harvested in orbit could flow back to the planet, altering human civilization on Earth itself. Likewise, Earth-based policies and culture may influence these colonies through laws, ethics, and communication. Humans may exist in a multi-planetary society, interconnected, yet physically separate, creating a complex web of interdependence. Artificial habitats may not only be functional but aesthetic. Interiors could mimic forests, oceans, or mountains, providing a sense of familiarity to inhabitants. These habitats may even be optimized for psychological well-being, designed to prevent the mental fatigue of living in confined spaces. Every detail, lighting, airflow, even gravity simulations would be calibrated to human survival and comfort. What seems like an ordinary corridor might be the product of centuries of research into how humans adapt to non-Earth environments. Evolution will continue, even in space. Populations on Mars may develop traits favoring low gravity, taller, thinner bones, different cardiovascular structures. Communities on orbital habitats may evolve to handle constant artificial lighting or recycled air. Cultural evolution will also be dramatic, as language, traditions, and governance adapt to conditions alien to Earth. Humans in space may become biologically and socially distinct, forming entirely new branches of the species. By the year 3000, humans may also begin to engineer ecosystems in space. Microbes, plants, and small animals could be introduced to closed environments to support life, regulate air and water, and even provide food. These artificial ecosystems will be delicate, carefully balanced, and constantly monitored. They are another example of how humans may shape life beyond Earth, blending biology with technology in ways that seem dully technical but are essential for survival. And yet, even with all this advancement, humans remain vulnerable. A single failure in a life support system, a solar storm, or a collision with debris could threaten entire colonies. The margin for error is smaller than on Earth. Survival in space is less about heroics and more about patience, planning, and the quiet maintenance of complex systems over centuries. So, when you imagine humans in the year 3000, picture them both on Earth and among the stars. They may inhabit the planet you know, but also moons, asteroids, and orbital habitats. They may be biologically enhanced, culturally distinct, technologically dependent, and yet profoundly connected to the survival challenges of their environments. Space may not be glamorous, but it may be essential for the continuation of the species. And here is the open-ended thought. In the year 3000, will humans still see Earth as home? Or will it be just one habitat among many? And if Earth becomes less hospitable, will the species survive only in artificial worlds, leaving the planet itself as a memory, a blue and green relic of the species that once walked freely upon it? Close your eyes and imagine the year 3000. You look around Earth and you see a planet deeply transformed by humans, by nature, and by the subtle interplay between the two. Technology no longer simply serves humans, it shapes the planet itself. It repairs damage, adapts ecosystems, manages climate, and even extends life in ways that seem mundane but are quietly profound. Start with the climate. By the year 3000, centuries of human activity, combined with natural cycles, will have shaped atmospheric patterns, sea levels, and temperature distributions. Yet humans may no longer be passive observers of these changes. They may actively manage climate through geoengineering carefully designed systems to reflect sunlight, capture carbon, or regulate ocean currents. Think of floating mirrors in orbit, enormous chemical scrubbers, or artificial clouds seeded to provide shade. These interventions are technical and unglamorous, but they could determine whether regions remain habitable or become inhospitable. Water management will be another quiet but crucial element. Rivers, lakes, aquifers, and rainfall patterns will continue to shift naturally, yet human systems may regulate flows. Dams, reservoirs, and underground aquifers may be engineered to balance scarcity and abundance. Water recycling may reach near-perfect efficiency, ensuring that even arid regions can sustain agriculture and cities. You might not see these systems as spectacular, but without them, civilization could collapse. Energy, of course, powers every adaptation. Solar arrays, fusion reactors, orbital energy collectors, and even bioengineered energy sources may dominate by the year 3000. The constant hum of infrastructure may seem dull, yet it allows everything else, cities, farms, space habitats, to function. Energy abundance also enables interventions in the environment. Artificial forests, climate regulation, water purification, and habitat restoration. Without it, humans cannot adapt, and the balance of life collapses. Forests, grasslands, and oceans may be shaped by both natural processes and technology. Deforested areas may be replanted with genetically optimized species. Coral reefs may be artificially supported, while fish populations are monitored and supplemented. Humans may actively manage ecosystems, introducing species where they are needed and controlling invasive ones. Life itself becomes a blend of natural evolution and human guidance, a quiet collaboration between biology and engineering. Agriculture will likely be radically different. Crops may be genetically engineered to withstand extremes, grow in deserts, or thrive under artificial light. Vertical farms, hydroponic systems, and controlled environment agriculture may dominate urban areas, while traditional farmland may either revert to wild ecosystems or be carefully managed for sustainability. Food production will be less dependent on chance weather, but more dependent on human ingenuity and ongoing maintenance. Animals will adapt alongside humans. Species that survive today may evolve to thrive in new climates, or humans may introduce replacements for extinct species. Some may even be artificially engineered to fulfill ecological roles, creating hybrid systems of nature and design. Forests, rivers, and oceans may contain species carefully curated for survival, yet still behaving naturally. Life on Earth may feel both familiar and strange, a patchwork of old forms, new adaptations, and human-guided evolution. Urban environments will also blend with nature. Cities may host green corridors, rooftop forests, vertical gardens, and artificial lakes. Urban planning will integrate ecosystems into human life, creating habitats for both humans and wildlife. Streets may hum with autonomous vehicles, drones, and energy-efficient transport systems. The mundane details of roads, pipes, and air circulation will matter more than ever, quietly sustaining life in ways that feel ordinary but are essential. History shows how humans adapt slowly to environments. Early civilizations depended on rivers for survival. When those rivers changed, so did their societies. By the year 3000, humans will be actively managing Earth's environment to suit their needs, ensuring that climate, food, water, and energy remain stable. Adaptation will be ongoing, iterative, and mundane. a constant adjustment that defines whether species, ecosystems, and human populations persist. One subtle but important factor is redundancy. Humans may have multiple systems for energy, water, food, and climate management. If one fails, others can compensate. Seed banks, genetic libraries, and artificial ecosystems serve as backups. These systems may seem dull, but they are critical. A minor failure in the wrong place could have cascading effects across cities, forests, and oceans. Survival will be a delicate balance maintained by planning, observation, and quiet maintenance. Pollution and waste management will be essential. Air, water, and soil must be continuously monitored and cleaned. By the year 3000, humans may have developed systems that neutralize toxins, recycle waste entirely, and even repurpose byproducts into energy or raw materials. It is not glamorous work, but it is the foundation for a thriving planet. Climate disasters, storms, droughts, and earthquakes will continue to occur. Humans may not prevent these events entirely, but technology may allow mitigation. Flooded areas may be contained, fires suppressed, and agricultural regions buffered from extreme droughts. Humans will act as guardians, smoothing the effects of natural variability while allowing the Earth to function. The planet itself will be less wild in the way you know it, but life will persist, guided by intelligent stewardship. By the year 3000, humans may have redefined Earth's ecosystems. Some areas may appear pristine, with ancient forests restored and wildlife thriving. Others may feel artificial, with engineered rivers, urban forests, and curated species. Life will be a collaboration, natural evolution enhanced by careful human intervention. It may not be natural in the sense you recognize today, but it will be alive, adaptive, and resilient. And yet, humans will remain vulnerable. Disasters, systemic failures, or mismanagement could undo centuries of effort. Even with advanced technology, life on Earth will require vigilance, planning, and patience. Survival is not guaranteed. It is the product of continuous adjustment. The quiet, repetitive work of monitoring ecosystems, maintaining energy and water, and preserving biodiversity will be the backbone of life in the year 3000. So when you imagine the year 3000, picture a delicate balance: technology, human adaptation, and the environment intertwined. Cities may hum with quiet energy. Forests may be both natural and engineered. Oceans may teem with life supported by human intervention, and humans themselves may be biologically and culturally adapted to thrive. The Earth may look alien in many ways, yet it will still be recognizably alive. And here is the open-ended thought. In the year 3000, will humans maintain this balance successfully, creating a harmonious coexistence with the planet? Or will the delicate threads of technology, adaptation, and environment unravel, leaving a world fundamentally transformed, with humans struggling to survive in the ruins of their own design? Close your eyes and picture the year 3000. Nearly 1,000 years have passed, and Earth and perhaps humanity has undergone transformation so profound that it may be unrecognizable. The planet is the product of natural forces, human intervention, and countless unpredictable events. By this time, nearly every detail, from the oceans to the forests, the skies to the cities, has been shaped, rebuilt, or transformed. Start with Earth itself. The continents will continue their slow drift, as they have for millions of years, subtly reshaping coastlines and mountains. Rivers may flow in new directions, valleys carved or filled, and deserts shifted. The ice caps may be dramatically reduced or partially restored, depending on climate cycles and human intervention. Sea levels may have stabilized, but entire regions that are bustling today could now be submerged, replaced by shallow seas or wetlands. What feels familiar may seem alien, yet it is still the same planet at its core. The oceans may be dramatically different. Acidification and warming could have reshaped marine life, creating new ecosystems that thrive under conditions unimaginable today. Coral reefs, if they exist, may be engineered or resilient, while fish populations adapt to changing currents and temperatures. Giant underwater structures, natural or artificial, could provide habitats for life, both terrestrial and human-engineered. The ocean remains vast, mysterious, and life-sustaining, yet altered by both human and natural forces. Forests and grasslands may be a patchwork of natural and engineered systems. Some areas may be restored wilderness, teeming with species that survived centuries of environmental change. Other areas may be carefully curated ecosystems, genetically engineered or artificially maintained to balance human needs with biodiversity. Humans may have learned to coexist with nature in a way that is both controlled and sustainable, a quiet stewardship that shapes the planet without entirely dominating it. Human life itself may have changed dramatically. Technology, medicine, and adaptation may have created beings that are biologically enhanced, culturally distinct, or even partly synthetic. Humans may live longer, think differently, and perceive the world in ways unimaginable today. Some populations may remain on Earth, others on Mars, moons, or orbital habitats. Interplanetary communication, culture, and cooperation may define existence, blurring the lines between who is human and what it means to be alive. Cities may feel more like integrated ecosystems than traditional urban areas. Vertical farms, green corridors, artificial lakes, and advanced infrastructure may blend seamlessly with nature. Roads, energy grids, and water systems may be largely invisible, quietly maintaining life without disrupting the planet's balance. Urban planning may focus not on spectacle, but on resilience and harmony with both human and natural systems. These cities may appear almost serene, a testament to centuries of careful adaptation, but survival is never guaranteed. Despite advanced technology, humans may still face challenges. Sudden climate shifts, pandemics, cosmic events, or technological failures. Extinction remains a quiet possibility. 1,000 years is a long span, and history is full of civilizations that vanished despite remarkable achievements. Humanity's continuation will depend on careful management, adaptability, and sometimes, luck. The balance of survival is delicate and continuous, a constant negotiation with forces both seen and unseen. Consider culture and memory. By the year 3000, humans may remember Earth as it was in your time through archives, literature, or digital memory. Ancient traditions may survive, adapted to new realities. Stories may be told of exploration, survival, and creativity, bridging millennia. Yet new cultures will flourish, shaped by new environments, technologies, and experiences. Memory becomes both a link to the past and a foundation for future adaptation. If humans vanish, life will persist in other forms. Microbes, plants, and animals adapted to the new conditions will continue the story of evolution. Ecosystems will reorganize themselves, and Earth will continue its slow, indifferent progression. Cities may decay into ruins, buried under sediment or reclaimed by forests. Oceans may wash over coasts once heavily populated. The traces of humanity, artifacts, structures, DNA, will linger as quiet reminders of what once was. Space may hold echoes of humanity as well. If humans survive off-world, the Earth may be one habitat among many, cherished, monitored, or partially abandoned. Distant colonies may thrive in ways unimaginable to current generations, carrying forward human culture, biology, and ingenuity. Humans may look back at Earth as a cradle once vibrant, once home, now part of a larger network of life in the cosmos. Technology itself may persist beyond humans. AI systems, infrastructure, and engineered ecosystems could continue to operate autonomously, maintaining conditions on Earth or in space. These silent guardians may be the last echo of human presence, quietly sustaining life or the planet's systems long after humans have disappeared. Even in the absence of people, human influence may remain tangible, embedded in the structures, machines, and modified environments that continue to function. And yet, the essence of life, growth, adaptation, resilience persists. Whether humans remain or not, the Earth will continue its story. Rivers will carve valleys, winds will shape dunes, forests will grow and decay, oceans will teem with evolving life. Time stretches forward, indifferent to individual species, but full of continuity and change. Life adapts, survives, and transforms. Always unpredictable, always evolving. So when you imagine the year 3000, picture a world of quiet transformations. Cities humming, ecosystems thriving or engineered, oceans alive with adaptation, and humans either thriving in ways you cannot imagine or absent, leaving Earth to continue its slow, patient evolution. Picture the balance between natural forces and human ingenuity, between survival and vulnerability, between memory and transformation. And here is the final thought to leave you with. In the year 3000, will Earth be a flourishing, managed paradise where humans and nature coexist in harmony? Or will it be a quiet, altered planet, carrying only echoes of the species that once walked, thought, and dreamed upon it? And if humans survive, will they still feel connected to you, to this moment in history? Or will the distance of nearly 1,000 years make your time feel like a faint, almost forgotten dream?